In the previous lectures, we see the area of the region bounded by the curve, axis and the given two lines. We also discussed the examples, that the area bounded between two curves. Okay. In this lecture, we see the examples in the miscellaneous exercise. Such type of the examples which are already done in the previous lectures. Now, here the example, it is a find the area of the region bounded by the following curve. Okay, there are the three examples, x-axis and the given lines. Here we know that the area bounded by the region. Okay, here area of the region bounded by the curve y is equal to f of x, x-axis, and line between the line x is equal to a and x is equal to b is given by, here the required area is integral a to b y dx. Here it is a required area. Y is equal to, it is a equation of curve y is equal to f of x, x-axis, and in between these two lines. Okay, now here the first example, here there are the two conditions. It is a 0 less than or equal to 5 less than or equal to x less than or equal to 5. Okay, here it is a condition for the x, that is condition for the boundaries, that is the x is equal to 0 and x is equal to 5 are the two lines. Okay, and here the curve, it is a y is equal to 2. Okay, now see carefully here the solution. Here the first, given that here it is 0 less than or equal to x less than or equal to 5 and 0 less than or equal to y less than or equal to 2. Okay, therefore here y is equal to 2, it is an equation of curve, is a curve. Okay, and that is, we know it is a y is equal to 2, it is a straight line. Okay, perpendicular to the y axis, and here x is equal to 0 and it is x is equal to 5. Therefore the required area is, here area is equal to integral a to b, that is a 0 to 5 y dx, and here integral 0 to 5 y, it is a 2 dx, integral of 2, here it is a 2x, 2 as it is, and here it is a x, and limit 0 to 5, and therefore it is a 2 into 5 minus 0, and it is 10 square units. Okay, it is our required area. Now in this example there is a diagram, is not necessary, but we see the diagram here. It is x-axis and it is y-axis. Now the equation of curve, that is it is a line, y is equal to 2. Here suppose this, it is y is equal to 2. Okay, it is x-axis, it is y-axis. Now we want to find the area bounded by this curve x-axis, and in between these two lines, x is equal to 0 and x is equal to 5. Here x is equal to 0, this line, it is x is equal to 0, and x is equal to 5, here it is x is equal to 5. Now we want to find this region, area of this region. Here we have to find the area of this region. Now we know that it is x-axis is a perpendicular to the y-axis, y is equal to 2 is also perpendicular to the y-axis, and the x is equal to 0 and x is equal to 5 are perpendicular to the x-axis. Therefore this area form a rectangle, and now this length it is a 5 and this length it is a 2, and therefore the area of the rectangle, it is a 2 into 5, that is 10. Okay, but in this question the diagram is not necessary. Okay, write only this calculation. Now we see the second example. Here example number 2, given curve it is given curve is y is equal to sin x. Okay, and here boundaries for the sin x, it is y is equal to sin x, it is a curve, and boundaries for the curve, it is x is equal to 0 to x is equal to pi. We know that it is x is equal to a and it is x is equal to b, that is a limit 0 to pi, and y it is a sin x. Simple area, it is the integral 0 to pi sin x dx. Okay, here it is area of region bounded between lines x is equal to 0 and x is equal to pi. Therefore, the required area is here 0 to pi, it is sin x dx. Okay, here 0 to pi sin x dx, and here the integral of sin x, it is minus cos x, and limit 0 to pi. Now upper limit minus lower limit, therefore it is minus cos pi minus, and it is minus, it is plus cos 0, upper limit minus lower limit, and then it is minus, it is minus 1 and plus 1. Okay, see carefully this. Here it is minus cos pi, it is a minus 1, and cos 0, it is 1. So we can write it is 2 square units. It is a required area. Now here see carefully, here limit, it is a 0 to pi. Okay, we know the graph of the sine, it is above the x-axis and also below the x-axis. Okay, here graph of the sine in the form of this, like that. Okay, but here it is a 0, here it is a pi, and it is a 2 pi. If our boundaries, it is a limit, here it is a 0 to pi, when the limit greater than pi, that means it is a below the x-axis. Suppose it is a 3 pi by 2, here it is a pi by 2, and here it is a 3 pi by 2. Okay, then our limit, it is x is equal to 0 and x is equal to 3 pi by 2. So we want to find the area by using the formula for the above the x-axis, the area bounded by the region above the x-axis and the below the x-axis. Separately we find these two areas. First find the area 0 to pi, and then we find the area, it is a pi to 3 pi. If the limit, it is given 0 to greater than pi, okay, but here it is a 0 to pi, so it is only the above the x-axis. So here it is a diagram in the form, it is x-axis, it is y-axis. Okay. Now here it is a 0, here it is x is equal to 0, and here it is x is equal to pi. And now we want to find the area of this region, and it is totally lie on the above the x-axis. It is y is equal to sin x, because in between it is 0 to pi. And now it is a required area. And the third example is the same. In given curve it is, but here limit, it is a 0 to pi by 3. Okay, here we know it is a 0, it is pi. Now here it is a pi by 2. Okay, and now pi by 3, it is a less than pi by 2, so here we get the pi by 3. Here x is equal to pi by 3. Now for the third example, we want to required area in this form. Here for the third example, okay, it is a sine. Okay, here it is a 0, here it is a pi, but we want to find the area between the region 0 to pi by 3. Okay, here it is a required area. Now for the third example, see carefully this. given curve y is equal to sin x, and it is x is equal to 0 and x is equal to pi by 3. Therefore, it is x is equal to pi by 3. X is equal to pi by 3, and here it is a pi by 3. Now, upper limit minus lower limit. Here, minus cos pi by 3, that means cos 60, and cos 60, it is 1 by 2, and plus it is 1. Therefore, it is a 1 by 2 square units. Here, it is a required area for this third example. Okay, for the second example, we find the area bounded by the complete region. It is a 0 to pi, but here it is a 0 to only pi by 3. 0 to pi by 3. Here it is a 0 and it is pi by 3. We want to find this area, and it is lie on the above the x-axis. Okay, see carefully. It is the first example. Now we see the second example. Now we see the second example. Find the area of the circle x square plus y square is equal to 9 by using the integration. Okay, here we want to find the area of the circle by using integration. We know the area of the circle, it is a pi r square, and here it is the equation of the standard circle, that is x square plus y square is equal to 9. That means the radius square r square it is. That means the area of this circle, it is pi r square, that means 9 pi. Okay, simply we say directly the area of the circle from this equation, but here we want to find the area of the circle by using integration. That means here we use the application of the definite integral. Here the area of the region bounded by the curve, it is a circle, x-axis and enclosure between two lines, that is the boundaries of the area of the region. Now here the given curve, it is a circle. Here given equation of circle, it is x square plus y square is equal to 9 with radius 3 units. It is the radius of the circle. That means it is the equation of circle x square plus y square is equal to r square. It is a standard circle. That means center at origin and radius is a 3 units. Now for the area bounded by the region, okay, first we find the y, that is y is equal to f of x. The equation of curve in the form of y is equal to f of x. So this can be written as it is y square is equal to 9 minus x square, and therefore y is equal to under root of 9 minus x square. Now here it is a x square plus y square is equal to 9. It is a standard circle. See carefully, it is a standard circle. Standard circle means center at origin. Here it is x-axis, it is y-axis, and it is a center. Okay, here standard circle, it is a center at origin and the radius given, it is a 3 unit. Okay, now we want to find the area of this complete circle. That means here the area of the region bounded by this curve axis and in between the lines, here the area of the complete circle lie on above the x-axis and also below the x-axis. But here the formula for the area, it is a to b y dx. Okay, here it is x is equal to a, x is equal to b are the boundaries of the region, y is equal to, it is the equation of the curve. Here it is the area, but this formula we use only for the region above the x-axis or the below the x-axis. That means f of x is greater than or equal to 0 or less than or equal to 0. Okay, here by using this formula we find only the area above the x-axis or below the x-axis. But here the area lie on above and below both. So first we find the above area and then the below of the x-axis and adding them, it is a complete circle. But we know that the above area, above the x-axis, the area bounded by the region, curve, and above the x-axis is same as the area bounded by the below the x-axis. That means we only find the area the above the x-axis. That means here it is a 3, it is 3, that means it is minus 3. The boundaries minus 3 to 3. But again here, this area in the first quadrant, see carefully, here it is a 1/4 the circle. That means the area of the complete circle is 4 times the area bounded by the region, by the curve in the first quadrant. That means this area, the area of the circle is 4 times this shaded region. Okay. Now here O, here we can take, it is A and it is B. Okay. Here O, A, B, O, it is a 1/4 of the circle. That means the area of the complete circle, it is a 4 times the area of this region. And area of this region is bounded between the lines x is equal to 0 and here it is x is equal to 3. Okay. Here 0 to 3, that means A is equal to 0 and B is equal to 3. But area of the complete circle is 4 times of this region. Okay. Now here area of the circle is 4 times the area of region OABO. OABO. Okay, and here the region OABO lie in between lines x is equal to 0 and x is equal to 3, and therefore the area of circle is equal to integral 0 to 3, sorry, it is 4 times 4 times integral 0 to 3 of y dx. Here y is the equation of curve, it is OABO here. Okay, this region bounded by this curve, line x is equal to 0, x is equal to 3 and the x axis, and therefore we can write here 4 into integral 0 to 3 y, it is under root of 9 minus x square. 9 minus x square, it is a 3 square minus x square dx. Here y, it is a 9 minus x square. Now here we use the formula for the integration, it is under root of a square minus x square. It is integral x by 2 under root a square minus x square plus a square by 2 sine inverse x by 2. Okay. Now we find first the integration for this. Here it is 4 times the integration x by 2 under root of a square minus x square plus a square by 2 sine inverse x by a here, and limit 0 to 3 here. Now calculate this upper limit minus lower limit, therefore it is a 4 into upper limit, see carefully this upper limit, it is a 3 by 2 into under root of 3 square minus 3 square plus 3 square by 2, that is 9 by 2. Here we can write 9 by 2 sine inverse 3/3. Here only we put the upper limit minus, now put the lower limit. Here it is a 0/2 under root of 3 square minus 0 square plus 9/2 sine inverse 0/3. Okay. Then here it is a 4 into, see carefully the calculation, 3 square minus 3 square it is 0, therefore first term will be 0, plus 9/2 sine inverse of 3/3 it is 1, sine inverse of 1 it is a pi/2. Okay, minus this 0 and this minus and plus it is minus, and sine inverse of 0 will be 0. And now here it is a 4 into 9 pi upon 4, and therefore 9 pi square units. It is a required area of the circle. Okay, see carefully this. The area of the circle डायरेक्ट एक काढता येते. एरिया ऑफ सर्कल काय, पाय आर स्क्वेअर. ऑब्जेक्टिव्ह मध्ये विचारलं तर डायरेक्ट लिहिता येते, पण शक्यतो या टाईपचे क्वेश्चन ऑब्जेक्टिव्ह मध्ये विचारणार नाहीत. विचारले तर चांगलं. ओके, एक्स स्क्वेअर प्लस वाय स्क्वेअर इज इक्वल टू 9. 9 मीन्स रेडियस स्क्वेअर. डायरेक्टली एरिया ऑफ द सर्कल 9 पाय स्क्वेअर युनिट्स. आता इथे एरिया ऑफ द सर्कल काढायचं आहे. हे तुमचं स्टँडर्ड सर्कल. ओके, आणि स्टँडर्ड सर्कल मीन्स सेंटर ॲट ओरिजिन. ओके, हिअर इट इज अ सेंटर ॲट ओरिजिन. देन मग सर्कल तुमचं हे झालं कंप्लीट सर्कल. देन आपण जे एरिया ऑफ द सर्कल बाउंडेड बाय द रिजन, हा जे फॉर्म्युला पाहतो एरिया ऑफ सर्कलचा, हा फॉर्म्युला काय, एक तर अबोव द एक्स ॲक्सिस एरिया असला तर काढतो किंवा बिलो द एक्स ॲक्सिस. एरिया एक्स ॲक्सिसच्या अबोव, एक्स ॲक्सिसच्या वर असला तर तो एरिया काढणार. कर्ण एक्स ॲक्सिस आणि दोन लाईन, या दोन लाईनच्या मधला एरिया एकतर lie on above the x axis or below the x axis, that is f of x greater than 0, f of x less than 0. मग हा या फॉर्म्युल्यानं फक्त एक तर above or below दोन्हीपैकी एकच एरिया काढणार. जर कर तुमचा above आणि below दोन्ही याच्यात असल्यास आपण दोन्ही सेपरेट एरिया काढणार आणि दोन्हीची ॲडिशन करणार. ओके, हे झालं तुमचा एरिया ऑफ द रिजन. मग आता इथं सर्कल एक तर above the x axis and below the x axis दोन्ही आहे. above the x axis आहे आणि below the x axis आहे. मग एक तर वरच्या रिजनचा एरिया काढा आणि खालच्या रिजनचा एरिया काढा. ओके, पण आपल्याला एवढं माहिती की इट इज अ डायमीटर, दॅट मीन्स वरच्या रिजनचा एरिया काढला अबोव द एक्स ॲक्सिस तर त्याला 2 टाइम्स 2 न गुणलं की झालं कंप्लीट सर्कलचा एरिया येईल. मग लिमिट काय येणार, हिअर हे इथून इथपर्यंत डिस्टन्स 3 असलं तर हे -3. मग लिमिट -3 to 3 हे घेण्यापेक्षा 0 to 3 घेतलं तर कॅल्क्युलेशन थोडं सोपं जाते. 0 to 3, एक लिमिट 0 आणि दुसरं लिमिट 3. तर आपण काय केलं, फक्त फर्स्ट क्वाड्रंटमधला एरिया घेतला. ओके, म्हणजे 1/4 द सर्कल, दिस एरिया इज 1/4 द सर्कल. मग याला 4 न गुणलं, हे झाले तुमचं कंप्लीट सर्कल. आपण 4 टाइम्स एरिया ऑफ द रिजन, दिस रिजन, इट इज अ एरिया ऑफ द सर्कल बाय युजिंग इंटिग्रेशन. ओके, आता सेम सर्कलचा जसा कन्सेप्ट आहे त्याच कन्सेप्टनं आपण काढणार आहेत एरिया ऑफ द इलिप्स. ओके, कन्सेप्ट पूर्ण हाच, फक्त काय इलिप्ससाठी हे डिस्टन्स आणि हे डिस्टन्स सारखं नसणार. ओके, हे दोन्ही डिस्टन्स वेगवेगळे असणार. बाकी मग कन्सेप्ट पूर्ण सेम. इलिप्सही 4 भाग येणार, अबोव द एक्स ॲक्सिस अँड बिलो द एक्स ॲक्सिस. पुन्हा सेम हाच कन्सेप्ट, एरिया ऑफ द इलिप्स इज इक्वल टू 4 टाइम्स द एरिया बाउंडेड बाय द रिजन इन द फर्स्ट क्वाड्रंट. ओके, पाहू याच्यानंतर एरिया ऑफ द इलिप्स. ओके, example number 3. Find the area of the ellipse x square upon 25 plus y square upon 16 is equal to 1 by using integration. Now here the equation of ellipse, x square upon 25 plus equation of the ellipse. X square upon 25 plus y square upon 16 is equal to 1. Okay, here compare with x square upon a square plus y square upon b square is equal to 1. Therefore a square is equal to 25. Okay, that means a is equal to 5 and b is equal to 4. That means the major axis along the x-axis, here it is a is greater than b. That means the ellipse, we can write the diagram of the ellipse here. It is x-axis, it is y-axis. Okay, now it is origin. Here this distance it is a 5 and this distance it is a 4. Here same concept as the circle. We find the area of this region A, O, B, O, and here this distance it is 5. That means here it is x is equal to 5 and it is x is equal to 0. That means the area of the ellipse is 4 times the area of the region bounded by the curve. That means this curve bounded by the curve x-axis, and in between the line x is equal to 0 and x is equal to 5. Now here the area of ellipse is 4 times the area of region OEBO, and here the region OEBO lie between the lines x is equal to 0 and x is equal to 5. X is equal to 0 and x is equal to 5. Now the area of this region, it is integral a to b y dx, but here the equation of curve it is x square upon 25 plus y square upon 16 is equal to 1. First find the y. That means this curve write in terms of y is equal to f of x. Okay. Now y square upon 16 is equal to 1 minus x square upon 25. That means 25 minus x square upon it is 25. Okay, and therefore y square is equal to 16 upon 25 is into 25 minus x square, and therefore y is equal to 4 by 5 under root of 25 minus x square. It is a y. That means y is equal to this f of x. Okay. Now the area of ellipse, therefore area of ellipse is equal to, it is 4 times the area of region this. Okay, we can directly write in the form of the integral. Area of this region lie in between 0 to 5 and it is the equation of curve. Integral 0 to 5 y dx, and therefore it is 4 into integral 0 to 5 y, it is 4 by 5 into under root of 25 minus x square, it is a 5 square minus x square. Now here we use again same formula. Here 16 by 5 into the integral of this term, it is x by 2 under root of a square minus x square plus a square by 2 sine inverse x by a, and limit it is 0 to 5. Therefore, put upper limit minus lower limit. Therefore, it is a 16 by 5 into upper limit 5 by 2 into under root of 5 square minus 5 square plus it is a 25 by 2 into sine inverse of 5 by 5, okay, minus lower limit 0 by 2 into under root of 5 square minus 0 square plus 5 square by 2 sine inverse of 0 by 5. Okay, and now calculate this. It is a 16 by 5. Here the first term will be 0, 5 square minus 5 square, plus it is a 25 by 2, and here it is a sine inverse of 1. Sine inverse of 1, it is a pi by 2, minus 0, and here it is a minus 5 square by 2, that is 25 by 2, but here sine inverse of 0, and sine inverse of 0, it is a 0. And therefore, the calculation it is 16 by 5 into 25 by 4 pi. See carefully, this 4, and then it is 4, and here it is 5. Therefore, it is a 20 pi square units. Here it is the area of the ellipse, 20 pi square unit. Here it is the ellipse, area of the ellipse. कन्सेप्ट सेम, सर्कलचा जसा कन्सेप्ट होता तसाच. डायग्राम तीच आली, फक्त सर्कलमध्ये काय रेडियस सेम असते, इलिप्समध्ये मेजर ॲक्सिस आणि मायनर ॲक्सिस. ओके, ही लेंथ सेम नसतात. मग सर्कलचाही एरिया आपण डायरेक्ट काढू शकतो, पाय आर स्क्वेअर. तसंच इलिप्सचाही एरिया डायरेक्ट काढता येते हिअर. ओके, डायरेक्ट एरिया काढण्यासाठी इलिप्स एक्स स्क्वेअर अपॉन ए स्क्वेअर प्लस वाय स्क्वेअर अपॉन बी स्क्वेअर इज इक्वल टू 1. देन area of ellipse is equal to AB pi square units. Okay, here it is the area of the ellipse, A into B into pi. In the circle both are the same, it is A. Therefore A into A, it is A square, but in the ellipse it is A and it is B, therefore it is A into B. Okay, here A into B pi, the value of A it is a 5, value of B it is a 4, therefore A into B 20 pi square units, it is the area of the ellipse. We can directly write for the objectives. Okay, but in the board exam the question will ask the 4 marks. Okay, and here the area of the ellipse by using integration like this.